Okay, let's try another example with method 2 for the Alberti cipher with advanced rotations. Let's start with a password called green. Eyed cat. And we'll add a number on the end of it. Let's use 33. Well, let's look through our password here and see if we have to use any digraphs or some other means of substitution. Yeah, we have a Y here. We have a choice that we can use either ZZ or maybe something else. I'm going to go ahead with the ZZ. So we'll do GREENEZZED cat. And then 33 is going to be a Roman numeral 33, which is XXX I. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19. So I am going to do something a little different here. I am going to encipher this with a transposition cipher, a rectangular transposition cipher, before going ahead and using the standard method 2 for Alberti. So I'm going to go 4 columns down, and I'm going to go 5 across. So let's see here. Well, that's kind of a messy grid. Let me try that again. Let's try that again. One, 2, 3, 4. 1, 2, 3, 4, 5. So we have 4 by 5 grid here. Now I'm simply going to write the password as we have pre-processed it here. GREEN eyed ZZ cat XXI. Whoops, one more X. Sorry about that. XXX I. And we have one leftover space. We won't worry about that. Okay. Alright, so now we're going to use this to pre-process it into a cipher. Because what we're going to do is we're going to superencipher it with the Alberti cipher. So this would give us, going by columns now, GECX, RZAI, EZTI, EEXI, and NDX. So that is going to be what we're going to start off with the Alberti cipher. Okay? Now what we'll have is a preface in front of this when we encode it that tells it that when you get this, that you have to drop it into a rectangular grid 4 by 5 and read it across. This is a rectangular transposition cipher. Is a pretty simple but very neat way to really mess up any cryptanalyst who's trying to make sense of your cipher, because they're going to be looking for words here. When they get this, they're going to go, no, this isn't right, because it doesn't say anything. So it's very doubtful that they'll go, maybe this is a superencipherment. So anyways, this is what we need to go to the next step. So let me clear off this grid now. Let's go ahead and rewrite this. G E X C. I'm sorry, G E C X. R Z A I E Z T I E E X I and N D X. So now we have to do the injection of the rotational commands. So we're going to get our two D4 dice and come over here and decide how we're going to do that. It says go over 4 and put in a 4. I'm not all that thrilled with giving away 4 positions, but let's go ahead and do that. G, E, C, X, and then we're going to have a 4. Go over 1 and then do a 2. Go over 1. R. And do a 2. Go over 3 and do a 2. Z. A. I. Go over 1 and do a 2. Go over 4 and do a 4 again. Z, T, I, E. Roll again. Go over 2 and do a 2. E, X. Do a 2. Go ahead with the roll. We go over 4 and do a 3. So we're on, I had a little interruption there, so I got to get back to this where we are here. EX. So we won't be putting in that 3 because that's essentially the end of it. So there we have it. Let's just make sure we still got everything. It should match this whole thing here, because we just essentially added rotational commands. So let's see if we have it. G, E, C, X. Okay, that's that. R, Z, A, I. Yes, we have that. E, Z, T, I. We have that. E, E, X, I. We have that. And NDX. NDX, we have that. So here we have a fully pre-processed and transposed message, which is now ready for the Alberti cipher. And what we're going to do with this, I'll go ahead and rewrite this, of course, up top here now, is I'm going to use this method here to control these rotations. And of course the rotations are going to be, I'll use my blue pen, X4, I2, E2, E4, and X2. Those are going to be the rotations, which are going to reference this chart over here. So let's go ahead and rewrite this over, and I'll come back to you. One thing before continuing is I forgot this R2, so it's actually 1, 2, 3, 4, 5, 6. There's 6 rotations here. 1, 2, 3, 4, 5, 6. X4, R2, I2, E2, E4, and X2. And of course we're going to get those meanings from over here. Now I've rewritten this over here in groups of 4, and under the number I'm going to put the definition as to what these rotations are going to mean. So we go GEC, and then we have an X4 right here. So then we look up X4, X4. So this is going to be a rotation of 3 to the right. Okay. And then right again we have another rotation, R2. So then we look that up, R2, which is another rotation. R2 is actually 2 to the right, so actually this pretty much performs like the old method system here. Okay. Then we go along here, we have an I2. Let's see what I2 gives us. An I2 gives us a B. So after we write down the value of 2, we're going to put the index, in this case a K, to the B. And then we have an E2. And E2 is going to be a 5, so a rotation to the right 5. And then we come over here, we have an E4. An E4 is again a rotation to the right 5. And then we have an X2. The X2 is going to be a P. So we line up under the P. So there you have the translated commands here for this. And now all we have to do is use the Alberti Cipher now and go ahead and encode this. And if I haven't made any errors, we should come up with quite the cryptogram here, which I really think very few people are going to ever get green-eyed cat out of. Okay, so let's just go ahead and write this out now. So first we're going to start with putting our K above the A, which is what I've been doing for all these. And now we're going to do the first 4, actually 5 characters just stock like this. So, wow, they'd get geckx, which, as you can see now that it is pre-enciphered, but transposed, isn't going to do them a heck of a lot of good. But let's go ahead and encode that for them. So let's see here. What do we get? So we're going to get, just double check here, K over the A. So we get a V, and then, this will go pretty quick because we got 5 characters here we're doing here, 5 symbols. R, C, just an N, and the X, which is a D. And then the 4, which is a G. Now, the X3 says go 3 to the right, so we're going to go 3. Really doesn't matter where you do this, by the way. So just go 1, 2, 3. I just kind of watched the lines, actually. The lines are really helpful. And then you go R2. Yes. And then a 2. D. The 2 is a 2, so we go over 2. Then we do a Z, which is a Q, and an A, which is a B, and an I, which is an N, and a 2. which is an H. But see, we have a letter here now. So now we take our K and we move it all the way back to B. See how that works? Nifty, huh? That really throws them off. Okay. So now K is on the B. We go for an E, which is a P. Then we go to a 2, which is an A. And we have a rotation of 5 to the right. 1, 2, 3, 4, 5. And we do a Z. This moves along pretty good. T, which is a Y. I, which is an L. An E, which is an E. A 4, which is an F. So as we move 5 again. 1, 2, 3, 4, 5. We go to E, which is an F. Go to an X, which is a Z. Go to a 2, which is a Y. Notice it's a rotate to P now. We find K. Where are you, K? And we take him to P. Only moves over 1. An I, which is a B. N, which is an E. A D, which is an I. And an X. Sorry, but my battery died during the encryption process here while I was filming. So here's the finished encryption, and I just checked it to make sure that it came out right, and it did. So this VRND GSDQ BNHP AMYL EFFZ YBEI V would be the encryption of our original green-eyed cat 33. So we'd end up with, of course, this coming out of it. And so we could rewrite that just to convert it back over to make sure you see it. So let's just take this off. And as you can see there in green, LOL, green for green-eyed cat, we would just now write this. Well, we'd first write it out to, we'd first look at it and then we'd X out all the numbers. So we'd go, okay, we don't need the 4, we don't need the 2, we don't need this 2, we don't need this 2, we don't need this 4, and we don't need this 2. And we'd have it in our command rule that we want to be in a grid that is 4 columns deep, or 4 rows deep, I should say. And as many wide as needed to hold this phrase. So we could count up what we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 4 times 5 would be 20, so that's 4, that's 8, 12, 16. We have 1, 2, 3, 4, one more, 20. Okay? So now we're just going to fill this down in the column here. G, E, C, X, R, Z, A, I, E, Z, T, I, E, E, X, I, N, D, X. So we've put it in its order again, and now we can just write across green-eyed. Of course, we have our digraph here. Eyed cat, and then 33. So there you have it. From initial inception to highly encrypted. This is actually super encryption, and then back again to an easily readable form. So if you've managed to sit with me through this whole video, I congratulate you, and you must really be interested in ciphers, and especially the ancient Alberti cipher, which, as you can see, is capable of doing some pretty neat things with a little mental gymnastics on your part. So thanks for watching, and have a good night.